Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna take a look at how we can set up something like this. I've done this a few times in the past, but this is actually the simplest we can do this. Um, Basically, there is one node responsible in order to create this. It's the Image Decompose. So this is another node in Sverchok that's dealing with image, other than the image node. So I think this is kind of worth talking about, and then it simplify everything. If you have like an image here, I get this emoji image, and you want to turn it into, like a bunch of circles with colors. You can actually turn this into 3D as well, but not gonna do it today. It's for another live noding. Okay, so yeah. This setup is rather simple, just the RGB, passing the RGB into the vertex color data. We can actually do like the image skipping as well, just load and unload, and if we want like more detail, we skip it less. There's this XY spread and etc., but that's can be for some other time. We can reduce the vertices, for example, and make this radius smaller. So this kind of a very kind of graphic design kind of work, but it might be useful depending on what you're doing. Yeah, so let's have a look at this image decompose from the scratch. So let's delete everything and turn on Sverchok. The nice thing about this setup is that we can do everything from inside Sverchok. So this is image decompose study 001. Let's pick an emoji first of all. Emoji smiley. Let's get one that's kind of interesting. I'll pick this one. Okay, emoji. How big is this emoji? Let's check it out real quick. This is around 160 by 160 pixel. So image decompose node in Sverchok, you just load the image this way. Currently, I don't think it can take a sequence of image yet, but maybe we can kind of hack it in different way. But just work on a single image first. Filter, don't worry about filter yet. This is actually quite interesting. You can use Python, I think, to do the filtering. Anyway, let's observe this XYA and RGB and the polygon. Yeah, let's get started. With a fewer draw, if we actually plug in the XYA, we actually should get a point position, and it says XY, and then the A is for the alpha. So we have alpha on this image, so alpha 0 and alpha 1. So that's something that you might or you might not want. We can separate it using a vector out and vector in. Just get the X and Y. So we have the position. We don't need the alpha, which is currently in the Z axis. So that's first. The RGB, you can guess, is definitely the RGB for each pixel. And the polygon, I have not tested. That's probably gonna output the polygons. Although I don't, yeah, actually that's gonna output this polygon exactly. So that means if you want like just a pixel art, we can use BMesh, viewer BMesh, and then turn on merge, because we don't want like too many objects. We just want a single object with all this data. I believe you can just plug in the vertices and polygon, and you will get this guy. And let's give it a try. Polygon, and then we're gonna switch to cycles, and we're gonna use the vertex coloring for this guy. Make sure it's face and the objects plug in there and the color goes in there, and just by doing that we're gonna get something. In the cycles materials, I have to make sure that this guy is using nodes. Let me check real quick. Create a new cycles node, and this is we have material.001. We're gonna use the vertex color, so just plug in attribute nodes and then specify sv call, because that's the data coming from Sverchok. Okay, so let's hope that this works. Face, and then etc. And then actually this guy is currently using diffuse. I just changed it to emission, so it's a self-lit material. Have a look, and we get a complete black. So I was wondering why, and then I realized one thing. The color coming from this RGB is actually very high details, which means if we check it on using the stethoscope, somehow it's like 0.01. It's very small value actually, and if we check it using viewer text, and let's check it out using this guy, text editor, you will see the value is like 0.00, 0.00. That means the value is really small. So I realized that, and then okay, apparently we need to multiply the color. This is actually I didn't know this, but I realized it after I'm checking the numbers, and then okay, then this is for precision value, so we can simply multiply it by 100, and we should get the RGB correctly. Red, green, blue, and go back to 3D view now. Okay, we have this. It's a little bit funky with this coloring. Maybe if we didn't skip any, reload this without skipping any color, we should get the result. Well, it's still kind of doing this weird thing. That's because of I think just because of the way the data being sourced and being outputted. This is not the most right way to do it, I realize, so we need to make a little bit of changes. Instead of using the polygon, I know there's a way to make this work, but I'm not gonna use this polygon. I'm gonna do it differently. I will use the matrix in, plug into that guy, and then the location should come from this guy, XYA, and then we can skip some pixel, reload the image. And for this guy, I'm gonna use a circle, and Sverchok just crashes, Blender just crashes. I'll just gonna restart. The explanation for that crashing is probably animation nodes and Sverchok nodes add-on kind of crashing each other. I don't know yet. It could be my computer as well. It happens time to time. Just need to reload. File, save as. Now let's get rid of this. We don't need. Just reload the image and then use a circle. Plug this into the viewer B-mesh. So circle with polygon, small radius 0.02. That should be good. Okay, so we have this arrangement, and then we have this vertex coloring. If we render, it should work. Okay, that's better. Currently, we have the background set to 1. The color is not right because I'm using this color management film light. Just change the exposure and the gamma. Should get the color that's matching. More or less, it's matching the emoji. So yeah, like I said, we need this multiplier 100. If I zero it out, I get like this is the red color, and then this is gonna be the green, and this is the blue value. You can definitely, you know, do some experiment here as well. So instead of just mixing all the color, you can use your own color. Let's say you want to multiply it with a random vector, you can do that. Vector math. So once you kind of separating all the data, currently you are accessing this image color data, and then you have all these numbers, and you can just simply mix it using your own numbers. So yeah, that's random colors kind of multiplied over the emoji. So how many value do we have? How many colors? Let's to check how many colors, you can use list length. Check this guy out. Use the stethoscope. (1024). Okay, plug that into the count. We have the exact number now. View top on orthographic. Okay, that's see, random color and emoji mixed together, because we are using this function called add. Add actually is like an addition. We can use subtract, get different result, maybe even multiply. Not multiply in this case because it's a vector. Normalize. Okay, that's interesting. Normalize. You get this a very subtle emoji. Anyway, you can play around with the numbers there. Again, we have a bit of control here with the image decompose, like XYZ spread. That's controlling the spread. The funny thing is the number doesn't change much. Oh, actually, that's because the value is like super accurate here somehow. XYZ spread. If I type in like 0.5, that's like very wide kind of image. 0.1. The Z spread, we don't use the Z's too much in this case, so don't worry about the Z spread. We have this, and we can render it out. Somehow it becomes brighter. Skip pixel. I don't know, I think it's being affected by many things. Exposure, gamma too strong. This guy actually have effect on the RGB somehow. Turn on the gamma. Okay, radius 0.02. back to our previous kind of setup. The nice thing about this is, of course, if we get out of Sverchok, we have this just a single image. You see, just alpha, and then we can just duplicate it if we want, and it will retain the information. If we change the emoji, for example, just unload that and then load a different image, open, just pick another emoji, this guy. This is emoji number 6. Just reload it. Now if we update it, it has both of them have this. Both of them now have different. The new emoji. I was thinking, okay, maybe it should have the other emoji. Maybe I need to use a different material. SV color. I was expecting this to have a different data. So we have that one. Maybe I should just replace this SV call. I have a feeling that they're using the same data here. Interesting. Maybe I should change this to beta. Now if I replace the image, and reload, we should get different emoji. This guy beta. Okay, yo, okay, that's that guy has a different emoji. You need to change the name of this data output, the mesh data output. This is the surface. Okay, I can zero that out, and then color management. Yeah, I think that's pretty much it for this live noding video. The setup is super simple here. You just use the image decompose and then just source an image, and then you are using the XY data plug into this. The circle can be any shape. If you have like a star shape, you can use that, and then it will update accordingly. Yeah, I think it's rather simple, but still it's kind of a good basic understanding of this RGB data, and then this is, I think, a really good example. XYZ for the mesh data, RGB for the color, and then this is, we are piping the data back into the vertex color. Yeah, I think that's pretty good. I might expand this tutorial into another different area, but for now I think that's pretty much it. If you have any question, suggestion, feedback, just let me know, and I'll see you in the next video. Thanks again for tuning in. Bye.